Welcome to this tutorial about using the European Climatic Energy Mixes or ECEM demonstrator. The quickest and simplest way to get to the ECEM demonstrator is to go to your web browser's address bar and type in ecem.wemcouncil.org. If this is the first time you have loaded the ECEM demonstrator, there'll be a series of prompts for you to navigate first. The first prompt will ask you to accept the cookie policy, and the second prompt will make you aware that this is a beta version and a proof of concept. This means we are still working to improve the demonstrator and even working on a new demonstrator for educational purposes. Given that this is a beta version, we are very much happy to receive feedback about what you like about the demonstrator and what we can improve. If you prefer to explore the ECEM demonstrator and get to know it at your own pace, in your own time, then you can take the quick tutorial. This is the main interface of the ECEM demonstrator, centered on a map of Europe. You'll notice that the spatial scale is by country, but you can choose clusters to go to a finer spatial resolution. Some variables that are available on the ECEM demonstrator are only available on a country spatial resolution. On the left-hand side, we have the console, which allows you to make selections. Underneath the console, there is a help box. Clicking on the red box will expand this help box, and it will give you many different options for documentation, frequently asked questions, glossaries, variable fact sheets, etc. In the bottom right, you'll notice that there is a legend and a slider. The variables that you could explore using the ECEM demonstrator are here on the left. These 7 climate variables are available for download as netcdf files on the CDS. The ECEM demonstrator also has some energy variables, which some of these climate variables are a component of. For the purpose of this tutorial, we will not explore every single individual variable, but instead focusing on 1 or 2 just to make you aware of how the demonstrator works. The simple approach is to start from top to bottom selecting what you would like. There are 3 time periods that you can explore these variables. Historical, which are the observed data between 1979 and 2016. Seasonal forecasting, which is a forecast of 3-month averages of winter and summer, and projections that use various energy and climate models. So let's take an example. Let's have a look at historical air temperatures at a daily resolution. Once the data is plottable, they will appear on the map. You will notice that as you make some selections, some options become unavailable. So in this instance, you can plot air temperature at a daily temporal resolution as absolute values, but you cannot plot them as anomalies or as a long-term mean. So this map is displaying air temperature at a daily temporal resolution, historical observed air temperature, and this is on the 1st of January 1979. The legend shows you the color and what is represented by those colors. So the darkest blue is minus 37.55 degrees Celsius, whereas the darkest red is 33.15 degrees Celsius. But if you mouse over an individual segment of the legend, it will give you the category classes and their ranges. So this very light blue is a range between minus 9.27 and minus 2.2 degrees Celsius. However, in order to aid you to analyze the map, you can quite simply hover your mouse cursor over a region such as Poland here, and it will give you the data point value. So on the 1st of January 1979, the daily average for Poland was minus 16.7 degrees Celsius. So this pop-up is a very good, handy way for you to access the data. The slider is a very, very powerful visual tool and helps you to manipulate the map through its temporal resolution that you have selected. Dragging the slider to the right moves you forward in time, and when you let go of the slider, of the mouse click, then the map will be displaying the date that you have selected. So in this instance, we are now viewing the 16th of June, 1986. And again, you can leave your mouse over a certain region or country, and it will give you that data point reading. This is a very powerful way of comparing visually two different time periods. So we can see that the 31st of December 2016 compared to the 1st of January 1979. Of course, using the slider allows you to visually, by sight, compare different time periods. However, you can also use the ECEM demonstrator to graph this data, and this will allow you to see if there are any trends or any significant differences between two time periods. To do this, click on a region or a country, so in this instance, Norway, and you'll notice that under time series plots, the country or the region will be displayed here. Clicking on New Graph will display this graph. So this is your historical air temperature at a daily resolution displayed as absolute values. And just like you can on the map, where moving your mouse will give you that data for that period of time on the map, moving your mouse over the graph will give you that data point for a particular point on that graph. So on the 5th of November 2002, the daily average for Norway was minus 4.58 degrees Celsius. The ECEM demonstrator also allows you to compare between regions or countries as well as between time. So selecting a second country in this instance, such as Spain, and clicking Add to Graph will allow you to compare between two different regions or countries. Let me show you that again, but this time at a different temporal resolution, which will give you an idea of how the ECEM demonstrator can display data in different ways. So here we have the historical air temperature as absolute values, but in an annual temporal resolution. So the average for Norway in 1979, for example, was 1.06 degrees Celsius. If I was to move forward through time, this time by clicking the play button here, I can go through an animation which shows the changes over time based on yearly averages. What is quite notable is that you'll notice that as we move forward in time, the reds become more prominent and the blues less so. Now if I was to plot a graph at this different temporal resolution, in this instance for Spain, you can see that this graph is essentially smoothed because we have moved from a daily temporal resolution to a yearly average temporal resolution. It's a bit easier to see trends over time in this instance. Let's now have a look at projections. And we'll show you how the ECEM demonstrator can give you extra options to explore different projections. We'll stay with air temperature at an annual temporal resolution for ease. We have two extra options here on the left-hand side that have presented themselves because we have now chosen projections. We have these different climate models, and you can click on the question mark to find out what these all mean. And we have different emission scenarios. An ensemble mean combines all these different climate models into essentially an average. RCP 4.5 is a quote low emission scenario, whereas RCP 8.5 is a quote high emission scenario, sometimes called business as usual. And just like before, we can visually see these temperatures on a map. Bearing in mind, of course, that these are projections based on models. But this time, rather than stopping at 2016, the slider will now go through to the end of the century. There is a new button underneath time series plots for graphs. This is called full plot. I'll click on that in just one moment. But first, Let's click on New Graph, and you can see the difference between this graph and the graph we used when we plotted historical temperatures. The smoothed annual graph appears as it did before, this time projecting to 2100 based on this emission scenario selected and an ensemble mean of climate models. But there is also an area here, which are the model's uncertainty. So by 2100, we could have a temperature range between 14.88 degrees Celsius and 16.66 degrees Celsius in Spain. Clicking Full Plot is a very powerful way of showing all the available data. The black is our observed temperatures. These are our projections based on our emission scenario. The blue being the low emission scenario of 4.5, and the brown being our high emission scenarios of 8.5. The individual lines are the individual climate models. If we change to energy, you will see that there are similar options available. Your variables are energy demand, hydro, wind, and solar power output. There are different variable types, and again, you have the same temporal resolutions. But this time, you have an extra function here. As well as being able to project according to climate models and by emission scenarios, there are also a number of energy scenarios also. You can explore what these mean by looking at the question mark or by going into the help function and exploring these boxes here. I hope this provides you with a simple overview of the ECEM demonstrator and its functionality. It is strongly recommended that you take some time yourself to go through the quick tutorial, to explore what you can find in the help box, and to generally have a play around.